Hello everyone. We have another problem where we have to graph some functions. The problem states the graph of y equals f of x is shown on the right, and part A asks us to find f of negative 4 plus 3, f of negative 1 plus 3, and f of 1 plus 3. So, we notice it's a little different from last time. Last time, the values that were being added, the plus 3, was outside of the brackets of the function, which meant that we were really just adding values to whatever the output of the function was. In this case, we're adding them to the inputs of the function. So let's get started. We have f of negative 4 plus 3. And we can easily simplify that. Negative 4 plus 3 is negative 1. So what value on the graph is where's f of negative 1? We have to the left 1. We have to go up 4. For negative 1, 4. So we have this output of 4 when our x was negative 4. Well, that's kind of getting ahead, but alright, let's try the next one. F of negative 1 plus 3. Well, let's reduce that to f of 2. And what is f of 2? Well, let's go to the right 2 spaces. And go up 1. We have 2, 1. So we have an output of 1. And then finally, f of 1 plus 3 is equal to f of 4, which on the graph is equal to negative 1. It's at this point right here. And that's it for part A. Alright, so part B asks us to graph y equals f of x plus 3. Now all of our values so far are on the function, so it might be a little hard to see where to go from here, but I think what we want to do is think of what our x values should be. So we really have two different functions, one being f of x, the one given to us, and one being f of x plus 3. Now we know some of the points on the function. Part A is just to somewhat find them. So we have negative 1 and 4. We have 2 and 1. And we have 4 comma negative 1. Those are all points on the original function. But notice in part A, if we were like kind of using this format of x plus 3, then this would be our x plus 3, x plus 3, and so on and so on. Whoa. Okay, so we have, like, in negative 4 plus 3, our x was negative 4. So if we were to graph that function, we'd have to make sure we were using the x value of negative 4. But our output was the same as what f of negative 1 was, which was positive 4. And on the second one we did, the x value we chose was a negative 1. And we got the same output as f of 2, which was positive 1. And similarly, when we used positive 1 as an input, we received negative 1 as an output. Remember, these are two different functions. So even though part A's answers were on the function itself, we have to remember we're using different inputs. Now let's graph those points. So we have negative 4, positive 4. We have negative 1, positive 1. And then we have positive 1, negative 1. Okay. Well, what's going on here? Well, think of this function as the set of all points where x is our input and f of x plus 3 is our output. Now, how is that different from the original function? Well, we note that when we were finding values on the original function, we wouldn't use like -4, for instance, as the input. We were using -1 as an input, where -1 is -4 plus 3. We used 2 as an input because 2 is what was -1 plus 3. So we took the x values that we're using here and added 3 to them, and then had the output of the function that's the same as this one. So we can rewrite this as the set of points x plus 3, because we kept adding 3 to those points, such that we have f of x plus 3 as our output. Okay, that's all nice, but like, where can that get us? Well, let's look at this endpoint. So that's -5 plus 1, 2, 3, 4, 5, 6, 7. Well, what would the corresponding value be on our new function? Well, we want the point, the same output point, right? F of x plus 3, but what would the original x value be? Well, corresponding to this x plus 3 on here that we have that is equal to the -5 over here. So if x plus 3 is equal to -5, if we subtract 3, we have that our x value is really equal to -8. So what we want to do is go back 8 spaces. So 1, 2, 3. And that would be our new point, -8, 7. And you can see that in each of these points we're shifting 3 spaces to the left to receive the proper output. And indeed, that is something that's going to hold. We're just going to take each of these points and shift it to the left 3 spaces. 1, 2, 3. So, now we can start connecting some stuff to make our new graph. Got this point, and then from here, and then down here. And we can see that in this new graph, we have shifted it to the left 3 spaces. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's the same exact graph that we had, just shifted to the left 3 spaces. So part C asks us, well, suppose f is a function, capital F. How is the graph of f of x related to the graph of f of x plus k? Where k is positive, what if k was a negative? Well, we know what happens when k is positive. If k is positive, the graph shifts to the left k spaces. If k is negative, it's going to do just the opposite. If k is negative, the graph shifts to the right k spaces. So that is it. Now we know that whenever we are adding or subtracting a value inside, or to the x value you could think of, we're going to shift the graph either to the left or to the right.